Good morning, everyone. प्राजक्ता, प्रज्ञा, निशा, चिराग, कादंबरी, नेहा, वैशाली, मीरा, स्नेहल, फरीन, आकाश, उत्कर्षा, आकाश सैंदाने, सायली, किशोर, अथर्व, किमया, राधिका, विशाखा, मानसी, हर्षल, अक्षया, मानसी पाटिल, पूजा, शिरीन, समीक्षा, श्वेतांजलि, पूजा पंचारिया, ममता, प्रतीक्षा, प्रणीता, नीतीश, निकिता, किरण तायडे. Good morning everyone. I hope my voice is clear to all of you. आवाज आ रही है आप लोगों तक? रमेश पटेल, गुड मॉर्निंग. हेमांगी, गुड मॉर्निंग. आवाज आ रही है आप लोगों तक? So good morning everyone. Rutuja, Leena, Raj, Namrata, yes audible. Nahid, Roshan, Prajoti. So as we have started with detector system, okay, Jagruti, good morning. We dealt with various aspects. We already covered with the instrumentation part. What are detectors? Ideal properties of detectors, we already discussed it. Selective properties and universal detectors. Then the list of detector system overview, will dealt it. UV. So comment in the chat box. How many types of UV detectors are there? Comment. Annan, good morning. How many types of UV detectors are there and which are they? Good morning Suprapti, good morning. Three types. Yes, Praveen, good morning. Which are they? Three. So these three are the types: fixed wavelength, variable wavelength, and photodiode array. These photodiode detector consist of how many photodiodes? The number photodiode detector consists of how many photodiodes? Yes. It consists of 512 to 1024 diodes. Okay, remember this fact because these facts are there in GPAT. Okay, yes, good, 512 to 1024. Okay, so indirect photometric detection where the chromophore is absent in case of your solute, then and if your mobile phase is going to absorb the light, because mobile phase contains the chromophore, in that case you just adjust the peak in such a way that the absorption by the mobile phase is considered as a negative, and as compared to this absorption your non-absorbing solute molecules will be compared. But as I already said, regarding if your compound does not contains any, yes, good, if your molecule solute of interest does not contains any chromophore, as we already discussed, chromophore is a functionality which absorbs the UV light and which shows the excitation so that we can detect the compound. But if that compound does not contains any functionalities, and if your mobile phase is such that it is sensitive to the UV light, in that case this is the one type that is called as the indirect photometric detection. But I already said, apart from the indirect photometric detection, there is one spectroscopic method called as a derivative spectroscopic method, in which you convert your solute by chemical treatment into another component. That means A is what the resolved solute. If suppose A is a compound which gets resolved out of the HPLC, you treat it with any chromophore B which shows absorbance at UV. Now by chemical treatment of A with B, you will get the C. Okay, and this C is a compound which shows the UV absorption just because it is attached to the B. Okay, and this derivative of A will show you the absorption because it contains a functional group, that is B, which is chromophore in itself, and such a derivative of A is useful to determine the concentration of actual A present in the sample, because you know how much of the addition of the B you have done, so that you can easily eliminate it and come to know that what should be the exact quantity or the concentration of A is. Okay, so such a type of determination is called as a derivative spectroscopic methods. So these are the cutoff wavelengths as we already discussed in the last semester itself. Some of the features of modern UV visible detectors. The UV visible detector, as already said, just because of its simplicity and easy operability, it has wide acceptability. Okay, so some of the features which we have developed nowadays: dual or multiple wavelength detection. Remember, it's not limited to the simultaneous or dual methods. It can be possible to analyze multiple wavelengths at a time. That means multiple wavelength detection can be possible by using modern UV visible light detector system. Okay, stop flow स्कैन, दैट डजंट मीन कि आपने अगर 200 to 400 स्कैन करने के लिए रख दिया तो जब तक 400 नहीं आता या 200 नहीं आता है तब तक स्कैनिंग बंद नहीं होगा. That means there are these so-called as a modern UV visible spectroscopic methods which involve the stop and flow scanning features. Somewhere in between you come to know that I will have to stop the procedure. You can easily stop it in between. Okay, the front panel access, just like ourselves, there are front panels available with the UV so that it becomes handy and easy to operate. Self-aligned sources and flow cells for easy maintenance. The operability of the UV detector has become so handy that these instruments become the part of the wide application in case of HPLC. Self-validation features are there. Okay, this is a unique feature in case of modern UV visible detectors. Remember, there are self validation features. That means you don't have to involve in outside validation features. These instruments itself validate themselves. Like power up diagnostics, they can validate it, how much of the power is required and how much is the present to maintain the efficient functioning of the UV visible detector. Okay. Leak sensor, if there is any part which is going to be leaked, or there is any component which is showing leak, that leak sensors will detect and you will be alerted at the appropriate time. Time locks for the lamps, if suppose the lamps, as I already discussed, lamps does not show higher lifetime, in that case that shows the highest amount of stability and what should be the peak hours or peak time for the lamps to get operated. Okay. Built-in holonium dioxide or rather oxide filters for wavelength calibration. You can calibrate the wavelength just like in case of our UV. We have calibrated the wavelength by using KCl solution, but that KCl solution needs to be prepared outside of the this UV visible spectroscopy. But in case of modern UV visible detectors which are specially designed for HPLC, they uses holmium oxide. Remember this term, holmium oxide filters, which can be used for self wavelength calibration. Okay. Filter wheels for linearity verification, there are filter wheels available, so that just like our colorimeter where that wheel is present for filters, these filter wheels can also be available for linearity verification. That means the linear wavelength we are getting is appropriate or not, is what that can be self validated features are there for UV visible detectors. Next is your refractive index detectors. I think there are 5 detectors only in case of our syllabus, so we will cover it. Okay. So as the word suggests, this includes RI, that is refractive index comparison. Now how they compare, with whom they compare, we will going to have a discussion. Measurement response is a function of RI. Okay. Refraction index difference between, important, between pure mobile phase and the mobile phase with the dissolved separated components. Okay. So refractive index differences, how they are going to measure it, or refractive index difference they are going to calculate it on the basis of running first the pure mobile phase. Okay. Or as we all know, there are 2 components with respect to the RI apparatus, where one component contains, just like our UV, the one cuvette will contains pure mobile phase and another will carry out the flow of mobile phase with dissolved separated components. Now when these 2 components, pure mobile phase plus mobile phase with dissolved components, show the differences in the refractive index, these refractive index differences will be detected by these detectors, and you will come to know the components and its quantity also by using differences in the RI, that is refractive index. Due to strong temperature dependence of the RI, a good temperature control of the measurement cell must be ensured. Remember, this is one of the disadvantage with respect to the RI detectors, because there is a density differences if you go for changing the temperature, and if you change the temperature, the RI will definitely going to be changed, and that's why you need to maintain a proper temperature stability in case of RI detectors. This is one of the disadvantage with respect to the RI detectors. The detection limit is in the range of 10⁻⁻⁶ to 10⁻⁻8 gram per ml. 10⁻⁻⁶ is microgram and 10⁻⁻8 is somewhere close to the nanogram, because nanogram is 10⁹. So we can call it as a refractive index sensitivity, or detection limit will expand from microgram to the nanogram. To achieve the high sensitivity, in practice solvents are selected that have a very high or low refractive index. Remember, if you go for refractive index calibration or rather scaling, scientists have generally chosen the solvent somewhere at the margin of this or this. Okay. What I mean to say, if you want the high sensitivity, then the RI scale की solvent system जब हम लोग डिटेक्ट करते हैं तो वो दोनों एक्सट्रीम पे चूज किए जाते हैं, आइदर अ वेरी लो RI, either a very low RI or either a very high RI, so that it cannot get intermingled or interlinked with any of the components, which majorly shows the middle part of the RI. Are you getting my point? RI जब हम लोग सॉल्वेंट चूज करते हैं तो सॉल्वेंट चूज करने का एक मेजर व्हाट वी कैन से मेजर कंपोनेंट क्या रहेगा या क्राइटेरिया क्या रहेगा, हम एक तो रिफ्रैक्टिव इंडेक्स सॉल्वेंट का इतना कम या इतना ज्यादा रखेंगे कि वो हमें सॉल्वेंट डिटेक्ट करने में मदद कर पाए, क्योंकि मेजॉरिटी ऑफ द सोल्यूट or analyte will show you the RI properties over this scale. Okay, now if your solvent will show you RI over here or here, it does not get intermixed or interacted with your component which is going to be analyzed. Okay, and you will get highest sensitivity. Hope this is clear. To ensure the difference between the refractive index of mobile phase pure and a mobile phase with dispersed solvents. Okay, so this is how it's just a simple mechanism by which you can easily compare the mobile phase RI with the RI of a mobile phase with a dissolved solvent. Now how it operates, as we all know, this refractive index, how it operates. One half of the measurement cell, the flow cell which is we are using in case of this, is half filled with a mobile phase. Okay, flowing mobile phase, which is a pure one. This is when there is a no sample, this half of mobile phase and this half of the mobile phase is purely of a mobile phase. Okay, sorry, when there is no sample, okay, let me erase it. When there is no sample and only your mobile phase is running through the flow cell, remember, only mobile phase is running through the flow cell, you will get the RI for mobile phase only. There is no deflection at all. Deflection cannot be occur because it is only single component. Okay, now the second half of the measurement cell, that is called as a reference cell, is filled with the mobile phase. The refraction index N, and it's first identical in both the cases because there is no difference in between the sample cell and a reference cell, because the mobile phase is filled with both the components. Okay, here is the first case where the sample cell and your reference cell is filled with the mobile phase. Okay, if the sample component is added to the element, okay, now they have done and added sample component in the sample cell, the refraction index N in the measurement cells changes. Just because there is a change in the medium, now the refractive index needs to be changed because there is a deflection of the rays passing out from this lamp. Okay, this deflection causes these amplifiers to detect the change in the deflection, and this deflection becomes the part of your RI analysis, refractive index analysis. Okay, so this is how this refractive index detectors work. Now there is a fluorescence detector. Okay, as the word suggests, fluorescence is emission property of certain compounds. Okay, emission properties of some certain compounds which emits the lights. This is the way these fluorescent molecules will look like. Okay, during the fluorescence detection, the sample is irradiated with UV light of a suitable wavelength and excited for the emission of a long wavelength. Remember, fluorescence spectroscopy, as we dealt it in the last semester, we come to know that there is no other that means UV light is what the source of a wavelength. What I mean to say is that there is no difference in between the UV light or UV spectroscopy and in case of fluorescence spectroscopy. Just difference is that the molecules undergoing the UV spectroscopy will show you the absorption spectroscopic technique or analysis, and in case of fluorescence spectroscopy, this shows you the excitation or emission spectroscopic analysis. UV light remains the same, that means the component or radiation source remains the same. Now if you know that the compound is a fluorescent one, you irradiate with the UV light, and these UV lights allows the molecules to get excited, or more specifically the electrons of the atoms will get excited and reach to the excited states. Now as soon as they reach to the excited states, they are bound to come to the ground state, and while coming to the ground state they emit the energy in the form of light, and that is what forms the basis of your fluorescence spectroscopy. Okay, we already dealt it with the compound or electrons. When they absorb the UV light, they get excited. Now in case of UV spectroscopy, the amount of absorbed intensity or wavelength will be detected, that will form the absorption spectroscopic basis. But emission spectroscopy, or more specifically your fluorescence spectroscopy, involves the emission of absorbed energy. Emission of this absorbed energy while coming back to the ground state from the excited state forms the basis of measurement of your fluorescence spectroscopy. Okay, the xenon lamp, which is also used in case of your UV spectroscopy, can continuously send the lights of 325 to 14 nanometer, where you can easily detect the fluorescent molecule. Provides the LOD values 100 times lower than the absorption detectors. What is LOD? Explain it. What is LOD? Definition. LOD. Now if these fluorescent detectors will provide you LOD of 100 times lower than the absorption detectors, then why we cannot go for fluorescence detectors over UV detectors? I need this answer from you guys. If this, let me know this, let me tell this. Okay, actually I will cover it. Limit of detection, that is what LOD is all about. LOD of fluorescence detector is 100 times lower than the absorption detectors. That means it shows the highest sensitivity and selectivity. Then why we cannot go for a fluorescent detector as compared to the absorption detectors? I am moving ahead. It is highly selective. Okay, it is highly selective. I think I have given you the hint also. And this is how the fluorescence detectors work. Okay, this lamp is there which irradiates the radiation sources. This is the excitation filter. Remember, the excitation filter needs to be there. There should not be the absorption filter, or rather there are two filters actually. One is the absorption filter and another is the excitation filter. But excitation filter allows you the passage of excited molecules energy, okay, that needs to be detected by these emission filters, which allows you to multiply on the basis of photomultiplier detector system. Okay, electrochemical detectors. Is there anyone who has got this answer? If LOD is so we can say sensitive for fluorescence detectors, then why we go for UV as compared to the fluorescence detectors? Yes, any one of you? if they have the capacity to detect 100 times lower amount as compared to absorption, some limitation for quantification, that is detection. Siddhi, can you elaborate it? Apart from Siddhi, anyone? Sir, we can pass through the selective wavelength. Anything else? Because all components doesn't show emission property. Good, Praveen, that's what I want. Actually, detection limit decides the amount of emission. Okay, now in case of fluorescence detectors, not every compound will show you the emission property as he has said. Okay, fluorescence detector needs to be the fluorescent molecules, and in nature or organic compounds, all of the or most of the organic compounds are non-fluorescent in nature. That's why this limits itself, because the chemical properties limits itself to the fluorescent detector as compared to the absorption detectors. Okay. Now electrochemical detectors, as the name suggests, there is electrical conduction between the chemical reaction. Okay, electrical conduction between the chemical reaction, that is also called as the electrochemical reaction. That means electrical conduction while converting A from B, it can be detected by using electrochemical detection system. Okay. Electron transfer processes offer highly selective and sensitive method, because electron transfer processes are selective in nature. That doesn't mean कि पॉजिटिव पॉजिटिव नेगेटिव नेगेटिव कहीं पे भी ट्रांसफर हो जाते हैं. अगर A से B ट्रांसफर हो रहा है इन प्रेजेंस ऑफ C, तो कौन से भी कंडीशन में चले जाओ आप, A से B ही कन्वर्ट होगा C इन प्रेजेंस. ओके, so these are what they forms a very selective and sensitive methods, just because there is a specificity in case of electrochemical reactions, and that's why these techniques are easily adaptable. You come to know that the titrimetric methods can be easily adaptable for any kind of circumstances or laboratory procedures. Okay, for use with the micro columns. Okay, as a background noise is dependent upon the mobile phase conditions, it is difficult to utilize these detectors with the gradient illusion separations. Remember, the mobile phase, which itself forms the components of these electrochemical processes, will affect your background noise, and hence these detectors cannot be utilized for the gradient illusion separations. That means these systems, so called as electrochemical detectors, needs to be useful for isocratic illusion system. Okay, because the mobile phase component which may affect your electrochemical reaction or the change in the composition of your mobile phase will affect the electrochemical reaction and thus the electrochemical detection system. Hence, it is difficult to utilize these detectors for the gradient illusion separations. Remember why they are important for isocratic as compared to the gradient, because the separation or rather composition changes in case of mobile phase will affect your electrochemical reaction, and that will denoted by the background noise in case of mobile phase, and hence the electrochemical detector system will be hampered because signal to noise ratio in case of this will be higher, and that's why the electrochemical reactions or detectors can be efficiently utilized in case of isocratic illusion systems only. There are two methods or the two types of electrochemical detectors: amperometric detection and coulometric detection. As the Coulomb system and ampere system you can easily determine by using the name itself. Here fixed potential is applied. Remember, the fixed potential in case of amperometric titration is applied to the electrodes. Okay, the two electrodes, reference and sample electrodes, which we have already covered in case of last semester. The amperometric detection system involves the fixed potential. Now the solute which will be oxidized at that potential yields an output current. The solute, whatever may be the constituents, okay, the solute, the amount of solute get oxidized at that potential, that fixed potential will forms you the output. But in case of coulometric titration or detection, 100% of solute species is converted. That means it consists of variable potential. Remember, the coulometric detection system will involve variable potential, and that's why not the most of the solute but whole of the solute will be get oxidized at the detectors, and you will get appropriate and excellent amount of results as compared to the amperometric detection. It offers the advantages of no mobile phase dependence, okay, on the signal and absolute quantitation through the Faraday's law, because there is 100% oxidation at the electrode surfaces by solute itself. So these amperometric and coulometric methods or detection system forms the part of your electrochemical detections. This is how we already dealt with it. The two electrodes, referent electrode and working electrodes, will be get oxidized, analyzed, oxidized or reduced depending upon the potential applied, and these are then get detected by your electro auxiliary electrodes. Okay, so this is how the electrochemical detector systems is there. There is one innovative technique called as the evaporative light scattering detectors. Okay, this ELSD. ELSD, evaporative light scattering detectors, can outperform the traditional detectors when analyzing non-chromospheric samples by the HPLC. Now, as we come to know that there are certain characteristics with which we will have to choose between the detector system, because UV requires a chromospheric sample, fluorescence requires what we can call as a fluorescent sample. Now, in case of also this RI and even this what we have called electrochemical reactions will detectors will require electrochemical reactions. Now, ELSD is some detector system which is helpful in case of non-chromospheric samples. Traditional HPLC detectors such as UV or RI have the limited capabilities because they will not yield you appropriate results when there is a non-chromospheric samples. Okay, UV and RI are not compatible with wide range of solvents also, as we have already dealt with the cutoff wavelength for the solvents, which makes it possible for us to choose between the limited range of the solvent, because other solvents will show you absorption maxima, and most of those solvents are present at the absorption maxima beyond 220 are non-polar in nature, which is efficiently and very widely used in case of HPLC. Now, if your non-polar solvent is showing the absorption in between the range of your compound, then that definitely affects your analytical techniques, and that's why UV and RI not compatible with a wide range of solvents. RI detection is not gradient compatible. Same case with respect to electrochemical, because RI system changes in the mobile phase composition cannot be easily detected by the sample and reference system. In case of refractive index, that means you need to maintain the constant flow of the mobile phase so that the detection system can be easily detected in case of gradient compatibility. So isocratic compatibility. Hence, this RI and UV are not compatible in case of gradient illusion. Different analytes produce different UV responses depending upon their extinction coefficient. No doubt about it. A 1% 1 centimeter, or rather these epsilon's values or absorption coefficient values will be different for different compound depending upon its lambda max, and that's why these different analytes will produce different UV responses. Okay. ELSDs can detect anything that is less volatile than the mobile phase. This is the one of the major advantage. Apart from these UV and RI's limited capability in case of wide range of solvents, in case of gradient compatibility, in case of non-chromospheric samples, these ELSDs can detect the samples which is less volatile than mobile phase also. Okay. ELSD is universal, first of its kind. That word you must have heard. in case of HPLC detector that this is the only detector which can be labeled as a universal and compatible with a wide range of solvents. Okay, so you can go for gradient elution also in case of ELSD. ELSD involves these techniques, 3 steps called as the nebulization, mobile phase evaporation and detection. How these techniques happen, we will have a short overlook over here. This is the instrument which utilizes ELSD detection system. नेबुलाइजेशन ये टेक्निक्स सिंपल है, अपने जो कोटिंग का क्राइटेरिया है उसी बेसिस पे है. नेबुला फॉर्म करना मतलब स्प्रिंकलर फॉर्म करना या ड्रॉपलेट फॉर्म करना. कॉलम इफिशिएंट पासेस थ्रू द नेबुलाइजर नीडल. ये नेबुलाइजर नीडल है आपकी, यहाँ से आपका एफ्लुएंट आ रहा है, मिक्सेस विद द नाइट्रोजन गैस. नाइट्रोजन गैस का सप्लाई भी इसको प्रोवाइड किया गया है. यहाँ से आपका एफ्लुएंट आ रहा है. ड्यू टू mixing with the nitrogen gas, which is an inert gas, droplets come out just because of the pressure exerted by the nitrogen gas. These droplets come out. This is called a nebulization step. Second step, mobile phase evaporation. Now these droplets pass through the heated zone. This is the heated zone. Mobile phase, as we all know, evaporates simply leaving the smaller sample particles. These dried sample particles remains because of evaporation of the mobile phase. And in the third stage, sample particles pass through the optical cell. Remember, this pass through the optical cell, and due to this the sample particles interrupts with the laser beam and scatter the light, because these are now solidified particles, small solidified particles. These have the capacity to scatter the light, and the amount of light scattered can be detected by the photodiode detectors. This forms the basis of your ELSD, evaporative light scattering detectors. Evaporative light scattering detectors, you can easily remember this. Evaporative, that means the solvent or the mobile phase gets evaporated, and the remaining light, remaining sample will allow you the light scattering, and this amount of light scattering can be detected by photodiode, which forms the basis of your ELSD. Okay. Now the last part, which is actually forms your self-study, so I am going it make it hurry. UPLC, ultra performance liquid chromatography, has been devised in 2004. Okay, so further advances in the column technology and chromatography instruments have been carried out with the help of UPLC. Now what UPLC stands for? It even utilizes the smaller packing particle size, which is 1.7 micrometer. Remember, the optimum particle size in case of HPLC is 3 to 5 or 10 micrometer, but UPLC is ultra performance or ultra pressure liquid chromatography, which utilizes the even smaller particles, higher pressure as compared to 15,000 psi as compared to our HPLC, allowed for significant increase in the liquid chromatographic speed. No doubt about it. Decrease in particle size, increase in the pressure will result into the speed increase, reproducibility and sensitivity. New research has useful that or make sure that the particle size as small as 1 micrometer and pressure up to 1 lakh psi can be possible with the help of UPLC. So contrasting HPLC with the UPLC, no doubt the first point itself is explanatory. UPLC gives the faster result and better resolution because smaller particle size and higher pressure. UPLC uses a less valuable solvents like acetonitrile, which causes the lower cost. The reduction of the solvent use is more environment friendly as compared to HPLC. The solvent which we are using not harmful for the environment also. Increased productivity can increase the revenue for the industrial setting, no doubt about it. Increase in the speed will result into increase in the productivity. Increase in the productivity will result into the increased revenue for the industrial setting. Apart from this, you can easily contrast with respect to the UPLC that UPLC employs higher pressure and smaller particles compared to the HPLC. Okay, so this summarizes your chapter on HPLC. I hope I think this is sufficient for you guys. We will cover the next topic in the next session. Okay. Other so you can share this with those parents. So that's all for today actually. So we will meet a Monday morning, Tuesday morning. We don't have the lecture, so we will meet Tuesday morning. Till then, take care.